Okay. So in 11 here, you have a ball and it's thrown in the air like this. Its speed is 14 meters per second, and the angle here is 35 degrees. So this one here would be 14 cos 35, and this one here would be 14 sine 35 when you break it into the two, like with the tension question we did earlier. So let me put that in as decimals. 11.47.
The one's 8.03.
8.03. Okay. So the ball will go up and then crash down.
This was the exam. This was the exam.
Was it? Maybe. I don't remember. I tried to forget about the mid-semester.
Can I get back up?
Maybe. If you want.
Because I want to see where I'm wrong.
I would rather forget about it, to be honest. I would just want to forget about it and move on. Alright. So part 1 is, I've just done it there, is get the components. So that's part A done. Part B. Now here's an interesting one. You want to work out the maximum height. Don't say derivative.
No.
Alright, okay.
It's when the vertical component is 0.
Vertical what component?
This one, the 8.03.
Yeah, what's that called?
Yeah, the
velocity.
Yeah.
Thank you.
And it gets to 0.
So if you look here,
Maximum.
when this is moving up in the air, when it's at the top, its Vy is 0. Because if you think about it, if I throw this up in the air, it starts to slow down, stop, and then fall back down. So at the top, the key thing here is that Vy equals 0. That's the key thing. Alright, what formula do we have for V? U plus, come on. V is U plus AT. And remember, we're only talking about vertical. So what's the U? Vertically? 8.03. And what's the A? Vertically? Minus 9.81. And the T we can find. That's what we want.
So I'm going to use the S, V plus U,
Now, just for MB, since he really likes his derivatives, alright, watch this MB. So what's the formula for the height? S equals UT plus a half AT squared. So the formula for the vertical height will be U T and then a half A T squared. Right, so tell me this. If the time is 0, what's the vertical?
So if you can T equals
Sorry, don't be confused. This is, I'm doing the same thing a different way now to get this.
I mean, it's a second, not meter.
Of course, you're absolutely right.
Okay.
Right. What's the formula for S? S equals UT plus a half AT squared. Yep. So if you look here, this is the formula for the height. So when T is 0, what's the height? 0. This is just like question 1 yesterday, isn't it? So how can I find the maximum height? What do I do? Derivative, what's the derivative here? 8.03 minus 9.81t should equal 0. So therefore t equals 0.819. Hey Abdal, you made it back. Come on. Yep. And then for part C, it should be the same. It'd be a problem if it wasn't the same. For part C, we put this back into this one here.
Part B, they need right?
Part B's want the time just. C is they want the height. So I'll put it back into this formula for height. And I get h equals 8.03 times 0.819 minus 4.905, 0.819 squared.
Oh, this
Yes.
is not the height.
What do you mean?
This is the displacement. And then we have the angle, right?
What are you,
This is the height.
what are you talking about, MB? This is the height. What else could it
Because
be?
we need the perpendicular height from.
This is the perpendicular height.
I think this gives us like the straight.
Oh, no, 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 no.
The house is like.
Yes, 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 yes. Mhm.
So because I use a different formula and I get C before I get B, can I do that?
Yep, no problem.
So it's minus between.
Yeah, that's a minus there.
Meter, isn't it?
Oh, yes. Yes, yes. Alright. Come on. There we go.